Welcome to Maths for All. I'm Aisling Flynn. This is exam practice. In this video we have a question on the circle. It's from the 2019 Ordinary Level exam paper, paper 2, question 4. The circle C is enclosed in the square PQRS and touches all four sides as shown in the diagram. The coordinates of three of the vertices, P, R and S, are given. And question A asks us to find the coordinates of Q, so the fourth corner over here whose coordinates we are not given. Okay, so what are we going to use to find Q? Well, we're going to use what we know about squares. Okay, in squares, opposite sides are equal in length and parallel. Okay, so we're going to use that fact to find Q, and we're going to use translations. So translations, or a translation, is a sliding movement across the coordinate plane. So if we take point S, which is here, and we look at the movement or the translation from S to R, if we copy that exact same translation, so the same direction and the same distance from P, then we should arrive at point Q. So that's what we're going to do. Okay, so let's study the translation from S to R. Okay, let's examine what happens. So let's look at the X values. So to get from point S to point R, the X value increases from -4 to +4. So -4, imagine the x-axis, you're going from -4 to +4. That is a total of 8 units, so you've increased by 8. So the translation will involve increasing the x coordinate by 8. Okay, and let's look at the y values. So to go from point S, we're starting at 11, to point R, we finish at 17. So to go from 11 up to 17, that's a rise of 6. So to go from point S to point R, we will be adding 8 to the x coordinate, and we will be adding 6 to the y coordinate. We're going to repeat that then, okay, to go from point P to point Q. Okay, so if we start with P, the x coordinate is 2, so we'll be getting 2 plus 8, which is 10. Okay, and the y coordinate is 3, and we'll be adding 6 to that, so 3 plus 6 is 9. So point Q will have x coordinate 10 and y coordinate 9. And there we have our point Q. Let's look at the marking scheme. So yes, they've used translations. So the x, actually they used a different two points. So they went from point S down to point P, and they've started at R and they went down to Q. Alright, so but still translations, and we still get the same result, 10, 9. Okay, there's 5 marks going for that part. Again, you can get partial credits as usual. Alright, low partial credits, that's 2 out of 5 if you did some work of merit, if you identified the translation on the diagram. So don't be afraid to draw onto your diagram. Okay, you'll get 2 out of 5. A high partial credit was 3 out of 5 in this case if you got one coordinate correct, so the x or the y, you get 3 out of 5. Or if you got your translation wrong but you applied it correctly, you get 3 out of 5. Okay, or applied your translation to an incorrect point. Okay. Part B, find the coordinates of the center of C. So we need a picture to do that. So C is our circle. We're looking for the center. So how are we going to do that? All of those corners are on the square. not the circle, and remember that Q was 10, 9. Okay, well, we can use the fact that in a parallelogram, if you join opposite corners, they bisect each other. Okay, and you'll get the exact center of your square, which is here. So really that's what we're looking for there. Okay, so how are we going to get it? Well, I use the word bisect, which means cut in half. So the center of the circle here will cut R, P exactly in half, or likewise you can go from S to Q, that will be bisected also. So cut in half or halfway, we're going to be looking at midpoint. Okay, and it doesn't matter which red line we choose. I think we'll use R and P. Okay, we'll look for the midpoint between R and P, and that should give us the center of the circle. Let's refer to our formula and tables booklet, the coordinate geometry pages, the line. It's on page 18, and we'll just remind ourselves of the formula for the midpoint of a line. So remember, we're getting the average of the x values, that's add them together and divide by 2, and the average of the y values, add them together and divide by 2. So recall, we're looking for the midpoint of RP to give us the center of the circle. Okay, what I'm going to do first is write down the formula. You'll see that perhaps we get some partial credit for that. Okay, I'm using points R and P. Alright, let's fill it in. So we have from R the x value is 4, and from P x value is 2 over 2, and the y values will be 17 plus 3 over 2, adding the top lines 6 over 2 and 20 over 2, and finally let's divide by 2 in each case, so we get 3, 10. So the coordinates of the center of that circle are 3, 10. Let's look at the marking scheme. Okay, we got the right answer. We used the midpoint formula, and yes, they use PR as well, but equally you could use SQ. Alright, again 5 marks going for that. Low partial credit, so 2 out of 5 if you wrote down the formula with some substitution, or if you indicated the center on the diagram. So that would be to draw the lines and how we would plan to find it. Okay, so don't be afraid to draw on your diagrams. High partial credit, 3 out of 5 if you use the formula and put in the numbers correctly. Part C, find the length of the radius of C. Okay, so we found the center, which was 310, didn't we? That was here someplace. 310. And we have to find the radius. So the radius is the distance from the center out to the edge of the circle. Okay, so we could go in any direction for radius. These are all radii. Okay, but how do we find it here? We've a number of ways we could go about it. We could perhaps find the point of contact here, which is the midpoint of SR, and use the distance formula. Or we could use the fact that this line here, R, is the same distance as this line here that I'm highlighting, R. And what is that distance? It is half the distance between points S and R, and indeed we could do this on any side of the square. Okay, so I've used the word distance and length. Alright, so we're going to use the distance formula. Let's remind ourselves of that. So again, we're on coordinate geometry pages, the line, and here we have the word length. We're looking at the length of a line. This is the distance formula we might use. Okay, reminding ourselves what we're aiming to do. So that was the center. We're looking to measure the radius, which we discussed would be equal to half the distance, we'll call it D, half the distance between S and R. Okay, so I'm going to write down my distance formula, which said that the line PQ, you get the distance by doing x2 minus x1 to be squared plus y2 minus y1 to be squared. Okay, so we'll calculate this first from R to S. Okay, and then we'll half it at the end. Okay, so I'm going to label my points here. Let's call R x1 y1, and let's call S x2 y2, and let's put in the numbers. So instead of x2 I have minus 4, so that's minus x1, that needs to be squared, plus y2 was 11, take 17, and that needs to be squared. Okay, so we get minus 8 to be squared plus minus 6 to be squared. Putting them in brackets because you must do minus 8 times minus 8, okay, and then we'll get positives. So 64 plus 36. And when you add those two numbers you get 100, so the square root of 100 is of course 10. So the distance from S to R is 10. So that would be a full diameter of the circle from side to side through the center. So our radius will be half of that. Radius equals 10 divided by 2, so R equals 5. Alright, let's check our marking scheme. So half of RS or half of SP, that's what we got. We used our distance formula. We put in the numbers, we got 10, and then we halved it to get 5. Okay, very good. That was 5 marks going for that. Low partial credit, 2 out of 5 if you wrote down the distance formula and put in some correct numbers. 3 out of 5 if you did your distance formula with all correct numbers. And actually, if you wrote down the correct answer without work, you get 3 out of 5 as well. So always show your work. Alright. And part D to that question then says find the equation of the circle C. Alright, so what do we know about it? Well, we found the center in part B, it was 310, and now we know the length of the radius, which is 5. That should be enough for us to write down the equation of the circle. Okay, let's just check our formula and tables books. So if you go to the second page of coordinate geometry 19, you'll find information on the circle. And given the center of the circle HK and the radius R, the equation of the circle is here. So this is what we're going to write down. Okay, this is what we're going to write down. So I'm going to transcribe that into my answer space. Again, I'll just put in our information here, 310 and radius 5. To get the equation of a circle, you do x minus h squared plus y minus k squared equals to r squared, and our h is 3 in this case, and k will be 10, and our r will be 5. So it's just substitution now. So we'll have x minus 3 to be squared plus y minus 10 to be squared equals to 5 squared for the radius. If you want, you can add another line and square out the 5, but it's probably not necessary. And this is what I'm giving as my answer, the equation of the circle. And let's check the marking scheme. So here are the marks for part D. There's 10 marks going for that. And did we get the correct answer? Yes, we did. So this is totally acceptable. If you wish, you could square out the brackets and simplify and get this version, but it's not necessary. Okay, so you will get 4 out of 10 for work of merit. Now what that means, you write down the formula, or you state the centre or the radius. You get 6 out of 10 if the formula is substituted. Okay, so we do have to square out the 5 squared, okay, to get 10 out of 10. If you made one mistake in your substitution but finished everything else correctly, you get 6 out of 10. Okay, full credit, correct or consistent answer without work. So if you just write it down, which is something we kind of did, okay, but it's good practice to write down your formula first, then substitute, and then work it out. Now, note here, accept work with candidate's centre and radius. So if you got the centre question wrong or the radius question wrong, but proceeded to do this correctly with those answers, you should get full marks. So that's, even though you think you might be wrong with the centre or the radius, it's a reason not to give up, to always keep trying the next parts, okay, because you may get some marks.